So today we will talk about the chemical properties of halogens. So first we will talk about the oxidation states. So you can see that all the members of this halogen family can show minus one state, but fluorine can only show minus one state, and others can show minus one, plus three, plus five, plus seven. So total six conditions are possible of these elements except fluorine. So now the condition arises that how it happens. So you can see that as you know that all these elements have similar outer configuration, that is ns2 np5. So I have shown the ground state where 2 electrons are present in the s orbital and 5 electrons are present in the p orbital. So when you have the ground state, in that condition the atom can either gain one electron or can share its one unpaired electron. In that case the oxidation number will be -1 or +1. Now in the first excited state you have three unpaired electrons. So by using three unpaired electrons we can make three covalent bonds and the state will be +3. In the state 2 we have total 1 2 3 4 5, total 5 unpaired electrons. In that case we can make 5 covalent bonds and the state will be +5. In the third state we have total 7 unpaired electrons. If the atom uses all the 7 unpaired electrons, so it will make 7 covalent bonds and the state will be +7. If we talk about the fluorine, so fluorine is the most electronegative element in your periodic table, and generally it can form ionic bond because of very high electronegativity, and it has no d orbitals. Now if we talk about reactivity, so as you know that when we move down in the group, so the electronegativity decreases, and the non-metals reactivity depend upon its electronegativity. So decrease in electronegativity means decrease in reactivity. So it means that the tendency to make ionic bond decreases. So in that case fluorine is most electronegative and iodine is least electronegative. Now point C is the oxidizing nature of these elements. What is the meaning of oxidizing nature? It simply means the nature to accept electrons from other atomic or ionic species in a reaction. For example, if you have an atom of an element and it reacts with the halogen molecule, so it will uh, get the negative charge and the atom of another element will get the positive charge. Now suppose that if you have an ion and it reacts with the halogen molecule, so it will get neutralized and it can form atoms or molecules, and again you will get charge on the halogen atom. So the oxidizing nature depend upon the electronegativity of the element. So more electronegativity, more will be the power to oxidize. So in that case fluorine is a very good oxidizing agent and iodine is least. Now if we talk about the oxidation of halide ions, so actually halide ions can oxidize each other. For example, fluorine being the most electronegative element, so fluorine can oxidize chlorine, bromine and iodine ions, and chlorine can oxidize bromide and iodide ions, and bromine can oxidize iodide ions. Next is a reaction with water. So when fluorine reacts with the water, it can form hydrogen fluoride and oxygen. So simply fluorine can change water into oxygen. Okay, and when chlorine or bromine reacts with water, they form hydrohalic acid and hypohalous acid. And the solution of chlorine in water and bromine in water is a very good oxidizing agent, and they are used in the laboratories. Now if you talk about the reaction of iodine with the water, so iodine has very less oxidation potential than oxygen, so it cannot change water into oxygen. So that's why this reaction is non-spontaneous. Okay, but if you have acidic medium, if you have acidic medium in the water, so iodide ion can react with oxygen to form iodine and water molecule. Now if we talk about the anomalous behavior of fluorine, so fluorine have a very high ionization enthalpy, very high electronegativity, and it has very high electrode potential, and it is also have very less ionic and covalent radii, less melting point and boiling point, and enthalpy of bond dissociation and electron gain enthalpy is also very less than expected. यानी जितना हमको expect है फ्लोरीन से, उससे कम values इनकी होती हैं. Now what are the reasons behind that? The reasons are, first is small size, second is highest electronegativity, third is low FF bond dissociation enthalpy, and non availability of d orbitals in the valence shell. तो ये चार सॉरी तो ये जो चार पॉइंट्स हैं ये बहुत इंपॉर्टेंट हैं कि फ्लोरीन इस तरह का बिहेवियर क्यों शो करता है. If you talk about the reaction of fluorine with other elements and the compounds of fluorine when reacts with other species, so the reactions are very exothermic. The reason behind the reactions are very exothermic is because of small and strong bond formed by it with other elements. यानी फ्लोरीन जब बॉन्ड बनाता है किसी दूसरे एलिमेंट से, तो वो बॉन्ड जो होता है वो बहुत ही छोटा होता है, और बॉन्ड जब स्मॉल होता है तो जब वो ब्रेक होता है तो उसमें बहुत ज़्यादा एनर्जी लिबरेट होती है. तो बिकॉज ऑफ हाई एनर्जी लिबरेशन द रिएक्शंस विल बी exothermic and sometimes explosive also. And the second important thing is that the fluorine can forms only one oxo acid. Why it can form only one oxo acid? Because it can't extend its valency more than one because of non availability of d orbitals. Now if we talk about the hydrogen fluoride, so among all the hydrogen halides like HCl, HBr, Hi, among these HF is the only hydrogen halide which is liquid at room temperature. Why it is liquid at room temperature? Due to the hydrogen bonding. And other halides are gases at room temperature. It's a very surprising fact. I think it is enough for you. Thank you so much.